Okay, we may or may not have had a chance to talk about matrix multiplication at the end of last class. If we did, then here's a little review. If we didn't, here it is, matrix multiplication. This is the trickiest of the operations with matrices, I think, because there's a dimension issue. It's very, very important, or it's only possible to multiply two matrices if the columns of the first equal to the rows of the second. And it's pretty easy to tell, because if you know the dimensions, say you have a 2 by 3, and you want to multiply that by a 3 by 1, remember, this is rows, this is columns, rows, columns. So the columns of the first must equal the rows of the second. And if that's the case, you can go ahead and multiply these. It's not a coincidence that the dimensions that are left, this row and this column, are going to be the dimensions of your product. That's kind of tricky. Let's try that again. Another example. If I have a 1 by 4 and I want to multiply this by a 2 by 4, I need to make sure that the columns of the first equal the rows of the second. In this case, it does not, so I cannot multiply. This is an operation that we simply can't do. Okay, so how does this multiplication work? Well, this is where it gets interesting. Let's try one. We'll work through one, try to pick a fairly easy example. Let's do a 2 by 2. So 1, 2, 3, 4. Remember, that's my favorite one. And we're going to multiply by a 2 by 3, which is 1, 3, 0, 0, 2, 2. Okay, so first thing we need to do is check the dimensions. This is a 2 by 2, 2 rows, 2 columns. This is a 2 by 3, 2 rows, 3 columns. So these both are equal. That means we can go ahead and multiply. That's a check. And a 2 by 3 is going to be the dimension of the product. So I'm going to go ahead and set that up. It's going to be 2 rows, 3 columns. Okay, so how we get these entries in that product is really the tricky part. And I'm going to see if I can change colors here. So the first thing we do is we identify this. We know it's a 2 by 3. Our product is going to be a 2 by 3. This is the first row, first column. Everyone see that? Whoops, you can't really see that. First row, first column. So if that's the case, I'm going to take the first row and multiply by the first column. And I'll multiply the corresponding entries and then add them together. So it's 1 times 1, which is 1, plus 2 times 0, which is 0. 1 times 1, 2 times 0. So I took this first row and I multiplied it by this first column. All right, and let's write the answer down here. So this very first one is going to be 1, that first entry. So to find this one, this is the first row, second column. So I'll take the first row and now multiply by the second column. So corresponding entries, 1 times 3 is 3, plus 2 times 2 is 4. 1 times 3 is 3, 2 times 2 is 4. So it's as though I took this and put it right there and multiplied those together. So 3 plus 4 is 7. First row, third column. First row, third column. 1 times 0 is 0, plus 2 times 2 is 4. And the answer is 4. Let's keep going. Second row, first column. That's the address of that one. I'll take the second row, and multiply it by the first column. Remember, it's always the rows of the first one multiplied by the columns of the second. So 3 times 1 is 3, plus 4 times 0 is 0, which gives me 3. Second row, second column. Second row, second column. 3 times 3 is 9, plus 4 times 2 is 8. second row times the second column. 3 times 3, 4 times 2, 9 and 8, 17. All right? And the second row, third column, second row, third column, 3 times 0 is 0, plus 4 times 2 is 8, which gives me an 8. So 1, 7, 4, 3, 17, 8 is the product of these two matrices.